300 meters beneath the surface of the Pacific Ocean, there is more heat right now than at any point since we have been able to measure it properly. More than 1997, more than 2015, and the peak is still months away. 4 scientists published that finding on Friday. 8 days earlier, the United States government published its own assessment of exactly the same ocean, and its headline number looked almost ordinary. Both of them are correct. They are measuring different things, and the gap between them is the whole story, because one of those numbers describes heat that has already been spent, and the other describes heat that has not. If that has you hooked, hit that like button and subscribe to the Skylab, because this one runs for another 9 months and we are going to follow every turn of it. And drop me a comment telling me where you are watching from, and whether this summer felt normal where you live. Now let's get into it. Part 1. 300 meters down. On August 21st, 2026, 4 scientists published a document that made a claim most people would assume was impossible to make this early in the year. They wrote that the El Niño currently developing in the equatorial Pacific Ocean is already the strongest in the modern record. Not on track to be, not projected to become, already is. And they wrote it, knowing that the maximum effects of this event are still months away. The names on that document are James Hansen, Pushkar Qureshi, Dylan Morgan and Jason Vest. It went out through Hansen's mailing list at Columbia University and through his newsletter, which he calls Climate Uncensored. If Hansen's name is unfamiliar, the short version is that he ran NASA's Goddard Institute for Space Studies for more than 3 decades and testified to the United States Senate in the summer of 1988 in a hearing that put the phrase global warming into ordinary conversation. If his name is familiar, you probably also know that he has spent much of the last 15 years arguing that the official consensus is too conservative, and that some of his colleagues think he pushes past what the data will support. Both of those things are relevant here. Hold on to them. What matters first is the measurement. Because the reason this claim sounds impossible is that if you go and look at the number the world normally uses to track El Niño, it does not say record. It says solid. It says respectable. It does not say anything like strongest ever. Hansen's group is not using that number. They are using the heat anomaly in the upper 300 meters of the equatorial Pacific Ocean, drawn from a NOAA index that covers the band of ocean running from 180 degrees west across to 100 degrees west. That is a slab of water roughly 1,000 feet deep and several thousand miles wide, and what the index reports is how much warmer that entire slab is than it ought to be. By that measure, the 2026 event has already exceeded the 1997 to 98 Super El Niño. That comparison is the whole reason this story exists. For almost 30 years, 1997 and 98 has been the benchmark. It is the event every subsequent El Niño gets held up against. The one that appears in every textbook chapter. The one that killed roughly 16% of the world's coral reefs and set fire to the peat under Indonesia and rearranged the weather of 5 continents in a single turn of the calendar. When forecasters want to describe the upper limit of what this oscillation can do to a planet, that is the event they reach for. And a group of scientists is now saying that in one specific and physically meaningful sense we passed it in August. Before the peak, before autumn, before the part of the year when El Niño actually does its work. So the immediate question is why they are measuring depth instead of surface. And the answer they give is worth reading carefully because it contains the argument the rest of this video is going to circle for the next 2 hours. Sea surface temperature, they write, is affected more by global warming than the 300-meter heat is. Sit with that sentence for a second, because it is doing something unusual. It is a scientist saying that the standard instrument for measuring El Niño has been contaminated by something that is not El Niño. The surface of the ocean is the part that touches the atmosphere. It is the part that responds fastest to a warmer world, the part that carries the fingerprint of everything humans have done to the air above it. If you measure El Niño at the surface, you are measuring El Niño plus 1.5 centuries of accumulated warming, and you have no clean way to separate them. Go down 300 meters and the picture changes. That water is insulated. It responds to the wind-driven redistribution of heat along the equator, which is what El Niño actually is, and it responds far less directly to the year-to-year state of the atmosphere. It is a slower, quieter, less contaminated signal. Here is a way to hold the difference in your head. The surface is what you can touch. The upper 300 meters is the reservoir underneath it, and a record in the reservoir alongside a merely respectable reading at the surface is not a contradiction at all. It is a statement about what has not been spent yet. That distinction is going to matter enormously in about 10 minutes. It helps to have a sense of the sheer size of what is being measured. The equatorial Pacific band that Index covers runs about 5,000 miles from end to end, which is further than the distance from London to Beijing. Take that width, extend it a few hundred miles north and south of the equator, and then go down 1,000 feet, and you're describing a volume of seawater that runs into the millions of cubic kilometers. Water holds something like 4 times as much heat per unit of mass as air does, and seawater is roughly 800 times denser than the atmosphere at sea level. Multiply those two facts together, and you get the number that governs everything in this video. The top few meters of the ocean hold about as much heat as the entire atmosphere above it. Go down 300 meters, and the atmosphere is not even in the same conversation. So when the index that tracks that slab of water reports an anomaly, it is not reporting a warm afternoon. It is reporting a quantity of stored energy that the atmosphere has no choice but to eventually absorb on a schedule the ocean sets and nobody else gets a vote on. The abstract of the document runs to 5 sentences, and every one of them is load-bearing. The first is the one we have already covered. The ongoing El Niño is already the strongest in the modern record. The middle sentences list what is happening around it: increasing global climate anomalies, the poleward shifting of climate zones, more extreme rainfall, faster developing flash droughts and fires, and marine heat waves, all of which, the authors write, are the result of accelerating human-made global warming. And then the sentence that gives this whole story its edge: the abnormal El Niño strength is itself likely human-driven. That is not a small claim. El Niño is a natural oscillation. It has been running for thousands of years. It shows up in coral cores and in ice layers and in the growth rings of trees on both sides of the Pacific, and it existed long before anyone burned anything. To say that the abnormal strength of this particular event is likely human-driven is to say that we have not merely built a hotter stage for a natural performance. It is to say that we have started changing the performance. I want to be straight with you about the status of that sentence. It is an assertion by a prominent group of scientists. It is consistent with everything else they have published. It is not a formal attribution study, and there is no attribution study in that document that establishes it. It is a professional judgment offered by people with the standing to offer it, and it is going to be argued about. We will come back to that argument in the last act, and we will give the other side a fair hearing when we get there, because the disagreement is genuinely interesting, and it decides more than people realize. The other thing worth noticing is that this is not a sudden announcement. The same 4 names published a communication on March 23rd of this year titled, roughly, Super El Niño, and then immediately, Super Warming is the main issue. They have been assembling this argument since the spring. What changed between March and August is not the thesis. It is that the ocean caught up to it, and Hansen's group is careful in a way that gets stripped out whenever this kind of thing travels. The phrase they use is that the usual measures of El Niño have blown past prior record levels in the period with good data. In the period with good data, that hedge is doing real work. The reliable index record for these measurements runs back to 1950. The well-constrained subsurface record, the one that depends on a genuinely modern ocean observing system, is considerably shorter than that. Every superlative in this story is bounded by how long we have been watching, and anybody who tells you this is the biggest El Niño in 10,000 years is telling you something the instruments cannot support. What the instruments can support is that in the era of good measurement, nothing like this has been recorded before, which is still, when you think about what depends on this particular body of water, an extraordinary thing to be able to say. Because the equatorial Pacific is not a remote curiosity, it is the largest single lever on the year-to-year weather of this planet. The temperature of that band of ocean helps decide whether the rains arrive in Ethiopia in September. It helps decide whether maize germinates in Zambia in December. It helps decide whether the Atlantic produces hurricanes this autumn, whether Australia burns, whether the monsoon reaches the wheat belts of northern India, whether the fisheries off Peru collapse or hold. There is a reason the phenomenon is named after the Christ child. Peruvian fishermen named it centuries ago for the way the fish vanished around Christmas. And the reason is that people whose survival depended on this ocean noticed it changing long before anybody had an instrument to measure it with. So when 4 scientists say that something in that ocean has never been recorded at this level before, and that the peak is still ahead, the honest response is not alarm and it is not dismissal. It is to go and check what everybody else is saying, which is where this gets strange. Because 8 days before Hansen's group published, the United States government published its own formal assessment of exactly the same ocean. Same water, same month, same instruments in some cases, and the headline number in that assessment looks nothing like the one you have just heard. Part 2, the same ocean, a different answer. The date is August 13th, 2026. The document is the monthly ENSO diagnostic discussion issued by the Climate Prediction Centre, which sits inside the National Weather Service, which sits inside NOAA. It is one of the least dramatic documents produced anywhere in the United States federal government. It is a page of text, it comes out on a schedule, and it is read closely by perhaps a few thousand people worldwide, most of whom do it for a living. The alert status at the top says El Niño Advisory, and then it gives the numbers. The July values were plus 1.4 degrees Celsius in Niño 3.4, plus 1.7 in Niño 3, plus 2.9 in Niño 1 plus 2. Those 3 names are 3 boxes drawn on the map of the Pacific, and they are nested more or less from the middle of the ocean toward the coast of South America. Niño 1 plus 2 is the small one, hugging the coast of Peru and Ecuador. Niño 3 sits offshore of it in the eastern equatorial Pacific. Niño 3.4 straddles the central and eastern basin, and it is the one that ended up becoming the standard, because it correlates best with the atmospheric response, with where the rain moves and where the wind shifts, which is what actually reaches people. Notice the gradient in those 3 numbers, plus 2.9 at the coast, plus 1.7 offshore, plus 1.4 in the middle. The heat is banked hardest in the east, exactly where the physics says it should be during an El Niño, and it thins out as you go west. The ocean is telling a coherent story. But the number that gets quoted, the number that appears in news articles and in your weather app and in the mouths of television meteorologists, is the middle one. Niño 3.4, plus 1.4 degrees Celsius, and plus 1.4 is a solid El Niño. It is a real one. It is enough to move a hurricane season and shift a monsoon. It is not a record. It is not close to a record. On the most widely quoted ENSO metric on Earth, in the month of July, this event did not look like anything historic. So we have 2 documents, published 8 days apart, both authored by serious people, both describing the same ocean, and one of them says strongest ever measured while the other one prints a number that reads as unremarkable. The resolution is in the same NOAA document. It is 1 clause, halfway through a dense paragraph, and it is almost never quoted anywhere. Subsurface temperature anomalies were significant, reaching plus 10.0 degrees Celsius at depth. 10 degrees. I want you to hold that number against the ones we just went through. The surface anomalies in that same document run from about 1.5 to just under 3 degrees. The subsurface anomaly is 10. It is not a global average and it is not a basin average. It is a localized anomaly within the body of warm water being displaced eastward beneath the surface. But it is sitting in the same paragraph as the surface numbers, and it is roughly 4 times larger than the largest of them. That is the fuel supply. Everything that happens to this planet's weather over the next 9 months comes out of that reservoir, and the reservoir is running an anomaly an order of magnitude beyond anything visible from a satellite looking down at the skin of the sea. There is a second clause in that same paragraph that tells you how the 10 degrees got there. The equatorial subsurface temperature index increased during July, NOAA writes, reflecting a deeper-than-average thermocline. The thermocline is the boundary layer where the warm surface water of the ocean gives way to the cold water underneath, and in the equatorial Pacific it is not flat. It sits deep in the west and shallow in the east, tilted like the surface of water in a bathtub that somebody has been blowing across for months. When that boundary deepens in the east, it means warm water has been pushed down and over on top of the cold water that normally sits close to the surface off South America. The cold water is still there. It has simply been buried, and the depth at which it now sits is the reason the surface can keep warming instead of being constantly refreshed from below. That is what a deeper-than-average thermocline means in practice. It means the ocean's break has been pushed further from the pedal, and that is the answer to the apparent contradiction. Hansen's group is describing the reservoir. NOAA's headline index is describing the surface. Both numbers are correct. They are measuring different things, and the thing that Hansen's group is measuring is the thing that has not been spent yet. The rest of the NOAA discussion fills in what the atmosphere is doing about it, and the atmosphere, it turns out, has already agreed to all of this. There are low-level westerly wind anomalies extending from the western to the east-central equatorial Pacific. In plain terms, the trade winds, which normally blow steadily from east to west along the equator, have not just weakened, they have reversed in places. Above them, at altitude, easterly anomalies are running the other way. That vertical structure is the signature of a fully coupled event. The ocean and the atmosphere have locked into each other rather than one of them merely reacting to the other. Convection and rainfall are enhanced from the central to the eastern Pacific and suppressed over Indonesia. That is the towering thunderstorm activity that normally sits over the maritime continent, picking itself up and walking east across open ocean, which is the single most consequential thing an El Niño does, because those storms are what steer the jet streams that steer everybody's weather. And the Southern Oscillation Index, the pressure seesaw between Tahiti and Darwin that Gilbert Walker identified in the 1920s, decades before anyone connected it to the ocean, was significantly negative in July, running near 2 standard deviations from normal. 2 standard deviations. In a normal distribution, you would expect to see that in roughly 1 month out of 40. The atmosphere is not ambivalent about this. Then comes the forecast, and this is where the NOAA document stops being unremarkable. El Niño is strengthening, it says, with a greater than 90% chance of a very strong event during the Northern Hemisphere fall and winter of 2026 into 2027. And then, for the October through December season specifically, there is a 69% chance of a historic event that would exceed the strength of previous El Niño events, dating back to 1950. Read that again. This is not a newsletter. This is not a scientist arguing with the consensus. This is the operational forecasting arm of the United States government, in its routine monthly bulletin, assigning better than 2-to-1 odds that the coming autumn produces the largest El Niño in the entire reliable record. So the 2 documents do agree. They agree completely. They simply arrive at the agreement from opposite directions. Hansen's group from a measurement of what is already in the water, NOAA from a probabilistic forecast of what the water is going to do with it. And to NOAA's real credit, the discussion does not stop at the headline. The very next sentence is a caution, and it is worth quoting because it is the sort of thing that gets edited out of every story written about it. With an event of this magnitude, they write, the chances of experiencing impacts consistent with El Niño are larger, but they are not guaranteed. That sentence is in there for a reason. El Niño loads dice. It does not write scripts. There are Decembers on record when a strong event produced almost nothing where forecasters expected everything, because the Indian Ocean dipole was doing something contrary, or because a regional circulation refused to cooperate. The forecasters closest to this data are the ones most insistent that you understand the difference between a probability and a promise, and we are going to hear from them again, more forcefully, in about an hour. But there is one detail in that 69% figure that we skipped, and it turns out to be the strangest thing in this entire story. The threshold is stated as plus 2.5 degrees Celsius or more for a 3-month Ronnie value, not ONI, Ronnie. If you have followed El Niño coverage for any length of time, you have seen the Oceanic Niño Index, the ONI, because it is the number that decides officially whether the world gets told an El Niño is happening. It is the index in the tables, in the archives, in the historical rankings that let anyone compare 1997 to 2015 to now. Ronnie is not that index. Ronnie is something else, and under that name, it did not exist in NOAA's operational products a year ago. The agency responsible for defining El Niño changed the definition. This year, quietly. And the reason they changed it is the reason we are all here. Part 3. How you actually build an El Niño. Picture the Pacific in a normal year and start not with the water but with the wind. Along the equator, the trade winds blow from east to west. They are not dramatic. They are steady, patient and relentless, and they have been doing it for as long as there has been an atmosphere organized the way ours is. Air warmed at the equator rises, spreads poleward, sinks in the subtropics, and returns along the surface toward the equator, and the rotation of the planet deflects that returning air westward. That is the whole engine. It runs on sunlight and spin. What those winds do to the ocean underneath them is the part almost nobody is taught. They drag. Month after month, year after year, that steady westward wind pushes the surface water of the Pacific ahead of it, piling it up against Indonesia and the Philippines and the scatter of islands that make up the maritime continent. And because water is not infinitely compressible, the pile has to go somewhere. It goes up. The sea level in the Western Pacific sits roughly 0.5 meter higher than the sea level in the Eastern Pacific. About 1.5 feet of ocean, held uphill by nothing but wind. That is one of those facts that sounds like an error the first time you hear it. The ocean is supposed to be the definition of level. We literally measure the height of mountains against it. But along the equator it is not level, it is tilted, and it has been tilted by the persistent shove of the trade winds for so long that a vast body of the warmest water on Earth has accumulated at the western end of it. Oceanographers call it the Western Pacific Warm Pool, and it is the largest reservoir of warm surface water anywhere on the planet. Underneath that pile, the boundary between the warm layer and the cold layer tilts too, the thermocline we met a few minutes ago. In the west, where the warm water is stacked deep, the thermocline might sit 150 meters down. In the east, off Peru, it can come within 40 meters of the surface, and because the winds are also dragging surface water away from the coast there, cold water rises to replace it. That upwelling is why the water off Peru is famously cold, why it is one of the most productive fisheries in the world, and why an anomaly that gets noticed within weeks by people who have never read a climate paper in their lives. Now weaken the wind, not stop it. Just weaken it, or in patches reverse it, which is exactly what NOAA reported this July with its low-level westerly anomalies. The moment the shove eases, the tilt starts to relax. That mountain of warm water in the west, which has been held uphill for years, begins to slump back east, and it does not do it as a surface current you could see from a ship. It does it as a slow, subsurface pulse, a bulge of warm water propagating eastward beneath the surface, deepening the thermocline as it goes, taking somewhere around 2 to 3 months to cross the basin. Oceanographers call these downwelling Kelvin waves. They move at a couple of meters per second, which is walking pace, and they are the single most important thing happening in the Pacific right now. As each one arrives in the east, it pushes the thermocline down. The cold water that would normally be upwelling into the surface layer can no longer reach it. The eastern surface warms, and here is where it stops being a physical process and starts being a trap. A warmer eastern Pacific means less temperature contrast across the basin. Less contrast means weaker pressure gradient. Weaker pressure gradient means weaker trade winds. Weaker trade winds mean less shove, which means more warm water slumping east, which means a warmer eastern Pacific. That loop has a name. It is the Bjerknes feedback, worked out by the Norwegian meteorologist Jacob Bjerknes in the 1960s, and it is the reason El Niño is an event rather than a fluctuation. Once the loop engages, it drives itself. The system does not need a continuing push. It only needed the first one. What eventually stops it is that the reservoir empties. The warm pool has a finite amount of heat in it, and once that heat has been redistributed east and exhaled into the atmosphere, there is nothing left to sustain the feedback. The trades reassert, cold water floods back, and often the system overshoots into La Niña. Oceanographers describe the whole cycle as recharge and discharge. Years of quiet, wind-driven accumulation, followed by a violent spending spree. Now put the 2026 observations into that machinery, one at a time, and watch how neatly they slot in. NOAA reports low-level westerly wind anomalies from the western to the east-central equatorial Pacific. That is step 1. The shove has eased. NOAA reports a deeper-than-average thermocline and a rising subsurface temperature index. That is step 2. The warm water is on the move east, and the cold water has been pushed down out of reach. NOAA reports convection enhanced from the central to the eastern Pacific and suppressed over Indonesia. That is step 3. The atmosphere has followed the water, and the thunderstorms have relocated. NOAA reports the Southern Oscillation Index near 2 standard deviations negative. That is step 4. The pressure seesaw has tipped, which is the atmospheric confirmation that the Bjerknes loop is engaged and running. 4 independent observations, 4 consecutive steps of a mechanism worked out 60 years ago. There is nothing mysterious about how this El Niño is being assembled. Every part of the construction is textbook. The only thing that is not textbook is how much material went into it, and there is one more consequence of that machinery that is worth naming, because it is the part that reaches people fastest. When the thermocline deepens off Peru, the upwelling that normally hauls cold, nutrient-rich water into the sunlit layer stops delivering nutrients. It keeps delivering water. It just delivers warm, empty water instead. The phytoplankton that feed on those nutrients thin out. The anchoveta that feed on the phytoplankton go deeper or go elsewhere. And the fishery that supports a substantial share of the world's fish meal supply falls off a cliff. That is not a projection. That is what happened in 1972, in 1982, in 1997, and it is why the phenomenon got a name from fishermen 400 years before it got one from scientists. They named it for the season it arrived in, around Christmas, and the name stuck to the child rather than to the wind. Which brings us straight back to the two numbers that disagree. The recharge is subsurface. The discharge is what you see at the surface. So in any El Niño, the subsurface signal leads and the surface signal follows, by months. When Hansen's group reports a record in the upper 300 metres, while NOAA's July surface index reads plus 1.4, they are not describing a disagreement. They are describing a sequence. The bank is fuller than it has ever been, and the withdrawal has barely started. There is an honest caveat here, and it is a big one. The conversion from subsurface heat to surface temperature is not a fixed exchange rate. It depends on where the heat sits, how the winds behave through the autumn, whether the atmosphere stays coupled, and a dozen other things. A bigger reservoir does not guarantee a proportionally bigger surface event, and anybody who tells you it does is doing arithmetic on a system that does not do arithmetic. Whether this record subsurface anomaly translates into a record surface anomaly is a genuinely open question, and it is the question we are going to end this video on. There is a shape to this argument that some of you will recognise, because we ran into it 10 days ago. In the video from August 14th on the Atlantic overturning circulation, the finding was that the variable which decided whether the current collapsed was not how much warming there was. It was how fast the warming arrived. 0.3 of a degree per decade was the threshold. Below it the ocean adjusted, above it it did not, and the researcher Henk Dijkstra put it in one line that has stuck with me since. The ocean simply cannot keep up. Hold that sentence. It is about to reappear in a different ocean, wearing different clothes, and it is going to be the entire second half of this video. But before we get there is something we need to settle about. The last time everybody was certain they understood what an El Niño was going to do, because it was recent. It was very recent, and the way it is now being reclassified is going to change how you remember the last 3 years. Part 4. The year we were told was the big one. You remember 2023. Maybe not by name, but you remember the shape of it. The run of announcements, hottest June ever recorded, then hottest July ever recorded, then hottest August, then hottest September, by a margin so large that several climate scientists said publicly they did not understand it. Sea surface temperature charts where the current year's line detached from the envelope of every previous year and climbed into blank space at the top of the graph. Ocean heat records, coral bleaching alerts, the phrase gobsmackingly bananas entering the scientific vocabulary because a researcher could not find a technical term that fit. It ran into 2024, and the world crossed 1.5 degrees of warming for a full calendar year for the first time. Everybody, including me, understood that as the signature of a very large El Niño arriving on an already warm planet. Here is what Hansen's group notes about that event, in a single parenthetical aside, almost in passing. By the upper 300-metre metric, the 2023-24 El Niño was only a moderate El Niño. Moderate, not strong, not super, not exceptional. Ordinary. A middling event, the kind that comes along every few years and does not get a chapter in a textbook. I have gone back and forth on how to present that, because it is the sort of fact that can be made to sound like either a reassurance or an alarm depending entirely on how you frame it, and it deserves neither. So let me just lay out what it means mechanically, and you can decide what to feel. It means that the most alarming 18 months of climate data in the instrumental record were produced by an event that, in terms of the heat actually staged in the Pacific reservoir, was unremarkable. The oscillation was ordinary, the result was not. Which forces a question that is genuinely uncomfortable, and it is not the question people usually ask. The usual question is how bad this El Niño will be. The better question is how much of what you remember from 2023 was the El Niño at all? Because if a moderate oscillation produced that, then a large part of what everybody attributed to the oscillation was not the oscillation. It was the floor the oscillation was standing on. And it is worth being specific about what that ordinary oscillation actually delivered, because the list has faded fast and it should not have. It delivered the fourth global coral bleaching event in recorded history, which NOAA formally confirmed on April 15th of 2024, and which ran on into 2025. Global bleaching events are not routine. There have been 4, ever. The first was in 1998, coming out of the event we keep using as our benchmark. This most recent one accumulated heat stress across the world's reef area at levels far beyond anything measured in the 3 that preceded it, and the gaps between events on the Great Barrier Reef, which used to be measured in decades, have now been measured in single years: 2016, 2017, 2020, 2022, 2024, 2025. It delivered a September global temperature anomaly so far outside the expected range that working climate scientists said publicly they could not account for it. The month had broken the previous record by a margin larger than the margin by which that record had broken the one before it, which is not how temperature records normally behave, and it delivered a full calendar year above 1.5 degrees of warming, crossing a threshold that had been treated for a decade as the central organising target of international climate policy. All of that came out of a moderate El Niño. Let me put some numbers underneath that, because Hansen's group does. During the 2023-24 event, land temperature reached plus 2.4 degrees Celsius relative to the 1880-1920 baseline. That is their figure, and the baseline they use is deliberately early. It predates most of the 20th century's industrial emissions, so it is a stricter reference than the more commonly cited pre-industrial windows. Plus 2.4 degrees, over land. And that number is doing something that the global average figures deliberately hide, because the global average blends land and ocean into a single number, and land and ocean do not warm at the same rate, not even close. Temperature change over land is roughly twice as large as temperature change over ocean. The physical reason is straightforward. The ocean has enormous thermal inertia, that heat capacity we talked about earlier, and it also cools itself by evaporating, which sends energy upward as latent heat. Land does neither. Soil has a fraction of the heat capacity of water, and once a region dries out, there is nothing left to evaporate. So all the incoming energy goes into raising the temperature instead of into converting water to vapour. Add that the land surface warms a shallow layer while the ocean mixes heat down through hundreds of metres, and you get a planet where 2/3 of the surface acts as a break and 1/3 does not. The 1/3 that does not is where everybody lives. So when the headlines report a global average anomaly of 1.5 degrees, almost nobody on Earth is experiencing 1.5 degrees. People standing on continents are experiencing roughly double it. The global average is a bookkeeping number for the planet's energy budget. It was never a description of anyone's summer, and the projection that follows from all of this is the number I would write down if you're only going to write down one from this section. Hansen's group expects land temperature to approach plus 2.7 degrees Celsius in 2027, almost 5 degrees Fahrenheit over land above the pre-industrial land baseline. Why 2027 and not 2026? Because El Niño's thermal signature lags its own peak. The ocean exhales heat into the atmosphere over months, and the atmosphere takes months more to distribute it. An event peaking in late 2026 writes its name on the following calendar year. This is why 1998, and not 1997, is the year everyone remembers as the record. The event was named for the winter it started in. The consequences were filed under the year after. A word of caution about the ranking itself, because I do not want to hand you a number to be overconfident with. Calling an event moderate on the subsurface metric is a relative statement. It is a position in a distribution of past events measured the same way, not a physical constant. The upper 300-metre index has a shorter, well-constrained history than the surface indices do, because it depends on an ocean observing system that only became genuinely global in the last 25 years. So the ranking of 2023 as moderate is a ranking within a modest sample, and it should be held with the same care as any other superlative in this story. What it is not, though, is arbitrary. Whatever uncertainty attaches to the exact placement, the direction of the finding is unambiguous. The reservoir behind the 2023 event was not exceptional, and the reservoir behind this one is. So the arithmetic problem sitting in front of us is this. A moderate El Niño on the planet of 2023 produced 2023. We are now being told to expect a record El Niño on the planet of 2027, which will be warmer still, and we have no analogue for that. None. The comparison set is empty. 1997 was a record event on a much cooler planet. 2023 was a moderate event on a warmer one. Nothing in the instrumental record is a record event on a planet like this one, which means every historical comparison you will hear over the next 6 months is missing one of its two variables. I want to be careful here, because there is a version of this argument that runs away from the evidence. This does not mean 2027 will be twice 2023. Climate impacts are regional. They are non-linear. They are mediated by the Indian Ocean dipole and by local circulation and by a great deal of chance, and there is no formula where you multiply a subsurface anomaly by a baseline and get a death toll out the other end. Some places on the risk map are going to come through the next 18 months without much happening at all. That is a real possibility, and I am not going to pretend otherwise. But the structural point stands, and it is the reason we are spending 2 hours here. If the moderate one did that, the records, the bleaching, the scientists who could not explain the September anomaly, then what does the record one do? That is the question this video is going to be about. Except that before anyone can answer it, there is a smaller, stranger, and much more concrete question that has to be dealt with first, and it has nothing to do with the ocean at all. It has to do with the ruler. Part 5. February and the quiet redefinition. In February of 2026, after roughly 75 years, NOAA's Climate Prediction Center changed how it defines El Niño. There was no press conference. There was a technical announcement, a set of explanatory documents, a new data page, and a handful of write-ups in the specialist climate press. Outside that world, almost nobody noticed, and I include myself in that. It is one of the least covered significant events in recent climate science, and I think the reason is that it does not look like an event at all. It looks like paperwork. What was replaced is the Oceanic Niño Index, the ONI. That is the number that has decided for 3 generations whether the world officially gets told an El Niño is happening. It is the value in the historical tables. It is what lets anyone sit down and compare 1972 to 1982 to 1997 to 2015. It is the spine of the entire archive. What replaced it is called the Relative Oceanic Niño Index, RONI. It is worth understanding what the old index actually was, because its design is what eventually broke it. The Oceanic Niño Index is a 3-month running average of sea surface temperature anomalies in the Niño 3.4 box, and an El Niño is declared when that running average sits at or above plus 0.5 degrees Celsius for 5 consecutive overlapping 3-month seasons. 5 overlapping seasons means roughly 7 months of sustained warmth. The threshold is deliberately conservative, designed so that a passing warm spell cannot masquerade as an event. It is a good index. It has done excellent work for decades, and the anomalies it uses are calculated against a 30-year base period, which is itself updated periodically in sliding windows, which is where the trouble starts. Because updating the base period does not just refresh the reference, it changes the meaning of every number that comes after it, relative to every number that came before, and the direction of the change is never random on a warming planet. It is always in the same direction, and it always makes the present look more ordinary than it is. And the reason for the change, in the agency's own framing, is one of the most quietly devastating sentences in modern climate monitoring. The traditional index measures a departure from a fixed 30-year average, and that fixed baseline struggles to keep pace with anomalous changes in tropical sea surface temperature, particularly in real time, when the climatology being used is already lagging behind. Let me translate that into what it actually admits. The reference ocean moved. Every anomaly is a comparison. When you are told the Pacific is 1.4 degrees above normal, you are being told the result of a subtraction. Today's temperature, minus normal. And normal, in the old system, meant the average over a fixed 30-year window. That is a perfectly sensible way to define normal, right up until the moment the average itself starts climbing. Because then the thing you're subtracting is moving, and your answer stops meaning what it used to mean. The tropical Pacific has warmed. All of it. Not just during El Niño events. The whole basin, the background state, the baseline. And once the baseline is rising, an index built on a fixed historical baseline slowly loses the ability to tell the difference between two completely different statements. It cannot distinguish this is an El Niño from the ocean is warmer than it used to be. It was, in the most literal sense, measuring the wrong thing. Not by much at first, but steadily and in one direction. The practical distortion this produced is worth spelling out because it cuts both ways, and that is what makes it a measurement problem rather than a political one. The threshold for declaring El Niño became progressively easier to hit, because the ocean was warmer to begin with, so it took less of an actual El Niño to clear the bar. And the threshold for declaring La Niña became progressively harder to hit, for exactly the same reason in reverse. The cold events had to fight through a warm background before they could even register, so the record was being graded generously in one direction and harshly in the other. Weak El Niños were getting promoted, Real La Niñas were getting demoted or missed entirely. And because those declarations feed into agricultural planning, insurance pricing, humanitarian prepositioning and government forecasting all over the world, the drift was not academic. It was operational. It helps to know who actually consumes that declaration, because the answer explains why a drifting index is not a filing cabinet problem. When the Climate Prediction Center declares an El Niño advisory, that declaration propagates. Agriculture ministries in a dozen countries adjust their planting advisories. Reinsurers reprice catastrophe exposure for the Atlantic basin. Grain traders reposition against expected harvests in Australia, Argentina, Southern Africa, and Southeast Asia. Humanitarian agencies begin the slow process of pre-positioning food and seed stocks in places where the pipeline takes months. Hydropower utilities in East Africa and Latin America revise their reservoir management. Fisheries authorities in Peru start planning quota reductions. None of those actors is reading the raw sea surface data. They are reading the declaration, and the declaration is a threshold crossing on an index. So an index that has quietly become easier to trip is not a statistical curiosity. It is a system that has started issuing more alerts than the phenomenon warrants, in one direction, while missing alerts in the other. And every one of those decisions is money, food, or water moving somewhere it may not have needed to move. The fix is elegant, and once you see it, you wonder why it took 75 years. Instead of comparing the Enso region against a fixed window from the past, Ronnie compares the Enso region against the rest of the tropics right now. Today's Niño 3.4 temperature minus today's tropical mean temperature. If the whole tropical ocean has warmed by a degree, that warming appears on both sides of the subtraction and cancels itself out. What is left is the part that is specifically El Niño, the redistribution, the anomaly relative to its neighbours, the actual phenomenon rather than the phenomenon plus the trend it happens to be sitting on. The effect this has on the numbers is the important part, and I want it stated clearly before we go any further, because it is going to matter in about 10 minutes. Ronnie dampens El Niños, it makes them look smaller, and it amplifies La Niñas, making them look larger. Both of those are corrections in the direction of what is physically happening, and both of them work against the intuition most people bring to a story like this. Now hold the timing in your head, because the timing is the thing. The ruler was replaced in February of 2026. By August, the strongest El Niño in the reliable record was developing in the ocean that ruler measures 6 months. That is the gap between an agency conceding that its century-old reference no longer worked and the arrival of the event that reference would have to judge. Which raises an obvious and slightly vertiginous question about what any record means now, and whether the number we are about to be handed can be compared to the numbers in the archive at all. Part 6. What happens when the average is also moving? Imagine you are timing a runner, and what you want to know is how far ahead of the pack she is. Every lap you record her position relative to the group. The gap widens and you write it down as a measure of how well she's performing. It is a good measurement and it works for years. Then the pack starts accelerating. Your runner is still improving, but your number, her lead, stops growing or grows more slowly or in a bad year shrinks. Nothing has gone wrong with your stopwatch. Nothing has gone wrong with the runner. The problem is that your measurement has 2 terms in it, and you have only been paying attention to one of them. That is the entire situation, and it is worth sitting inside it for a minute, because I think it is the single most useful idea in this video, and it applies to far more than El Niño. Every anomaly you have ever been quoted is a subtraction. Degrees above average, percent of normal rainfall, standard deviations from the mean, snowpack as a fraction of median. In each case there is a measured value and there is a reference, and the number you get handed is the difference between them. Public attention lives almost entirely on the first term. The second term is treated as furniture, fixed, neutral, uninteresting, the thing the measurement rests on rather than part of the measurement itself. But the reference is a choice. Somebody picked a window. And the convention in climate and weather monitoring is a 30-year window, updated every 10 years, which means that periodically, quietly, on schedule, with a technical note, normal gets redefined. Think about what that does. The same physical ocean on the same day can produce a smaller printed anomaly simply because the reference window was refreshed, and the new window includes more warm years than the old one did. The water did not change, the subtraction did, and a reader looking at a chart of anomalies over 50 years is looking at a quantity whose definition has been silently updated underneath it, several times, in a direction that flattens the trend. You have almost certainly been handed one of these without noticing. Snowpack reported as a percentage of median is the classic case. If a basin is at 80% of median in April, that sounds like a shortfall of 1/5, and it is, against a median calculated over a window that may include decades during which that basin reliably held far more snow than it now does in a good year. The percentage is arithmetically correct and quietly reassuring, because the denominator has been sliding toward the numerator the whole time. The same basin can hold less water each decade while its percentage of median figure holds roughly steady, and nothing in the reported number will tell you that is happening. Real time is where this bites hardest, and it is the specific problem NOAA named. A forecaster in August of 2026 comparing today's ocean against a window that closed years ago is not comparing today against now. They are comparing today against then. On a stable planet, that distinction is trivial. On a warming one, the lag is a systematic bias, and it grows every year the window ages. Work it through with round numbers and the arithmetic becomes obvious. Suppose the Niño 3.4 box sits at 1.5 degrees above its historical 30-year average. On the old index, that is a strong El Niño, and the headline writes itself. Now suppose the entire tropical ocean belt, the Indian, the Atlantic, the Western Pacific, everything between the tropics, has also warmed by 0.5 degree relative to that same historical window. That 0.5 degree is not El Niño. It is in the water whether or not the trade winds ever falter. Subtract it, and the part that is actually El Niño is 1 degree, not 1.5. The old index printed the sum of two things and labelled it with the name of one of them. Run that forward a few decades and you can see where it ends. If the tropical background warms enough, the old index would eventually declare a permanent El Niño, a state of affairs in which the Pacific is officially in an El Niño every month of every year, forever, which would be a meaningless statement about a phenomenon defined by its coming and going. The index would not have detected anything. It would have simply run out of the ability to say no. This is not a problem unique to ENSO indices, and it is worth taking one step outward to see the shape of it, because you have run into this before without knowing it. Floodplain maps are drawn against a statistical distribution of past river flows. Building codes specify design loads against historical wind and snow. Drainage culverts are sized to a storm intensity taken from tables. Every one of those is an anomaly problem in disguise, a present-day decision anchored to a reference that was assumed to hold still. When the distribution drifts, the map is not wrong about the past. It is simply no longer a description of the future, and nothing on the map says so. The index change is that failure mode caught early, in one specific instrument, by an agency that noticed. Now, what Ronnie does not fix. It removes the tropical mean warming trend from the ENSO signal. It does not remove the warming from the world. The heat is still there. The ocean is still hotter than it was. Ronnie simply stops crediting that heat to El Niño, which is the correct accounting decision, and also a slightly disorienting one, because it means the official El Niño number is now deliberately blind to a large part of why the water is warm. That is the trade. Ronnie makes El Niño events comparable across decades again, which restores the archive. The cost is that the printed number becomes a worse guide to how hot the tropical Pacific actually is on any given day, because it has been engineered to ignore exactly that. Two different questions, two different instruments. A record on one does not have to be a record on the other, and if you have been paying attention, you will have noticed that this is now the second time in this video we have hit that same structure. Hansen's reservoir against Noah's surface, and now Ronnie against Oni. The pattern is not a coincidence. It is what happens to every measurement system when the thing it measures against stops holding still. Which sets up the obvious test. If the new index is specifically designed to make El Niño events look smaller, then the interesting question is what happens when you run this year's event through it. Part 7. The record that survives the correction. Go back to the sentence from the August 13th discussion and read the part we skipped. During the October to December season, there is a 69% chance of a historic event that would exceed the strength of previous El Niño events dating back to 1950, plus 2.5 degrees Celsius or more for a 3-month Ronnie value. Ronnie, the conservative one, the one that dampens El Niños by design. That is the whole point of this act, delivered in a single line of a routine government bulletin, and it is the reason the index change matters rather than being a footnote. This event is not clearing the bar because somebody handed it a generous ruler. It is clearing the bar on the strict ruler, the one built specifically to subtract global warming out of the measurement, the one that makes every El Niño look smaller than the old system would have said, the one whose entire design purpose is to stop warm oceans from being mistaken for strong El Niños. And on that ruler, NOAA gives it better than 2-to-1 odds of being the largest in the entire reliable record. And there is a second consequence of stating it in Ronnie that most coverage will miss entirely. Because the historical series was recomputed in the new index all the way back to 1950, the comparison being made is not this year's Ronnie against 1997's Oni, it is like against like. Every past event has been put through the same correction, which means 1982 and 1997 and 2015 have all been regraded on the strict scale too, and they have all been marked down. So when NOAA says this event could exceed everything back to 1950, it is saying it exceeds a set of benchmarks that were themselves shrunk by the same procedure. The archive was not left behind, it was brought along, and the comparison holds. I want to deal with something here directly because if I do not deal with it, you will see it in the comments within an hour of this going up, and the people saying it are not being stupid. The claim is that the index was swapped to hide something, that the timing is too convenient, that an agency changed its own scorekeeping 6 months before a record event, and that whichever direction you think the manipulation runs, the manipulation is the story. Let me take that seriously and then let me show you why it does not survive contact with the actual change. If the goal were to make the climate situation look more alarming, you would not adopt Ronnie. Ronnie makes El Niños look smaller. It takes the warmest, most headline-friendly ocean readings and subtracts the global warming component out of them before printing the number. An agency trying to manufacture alarm had a far easier option available. Leave the old index alone and let a warming baseline inflate every El Niño for the next 50 years. That was the status quo. They walked away from it. If the goal were the reverse, to downplay the situation by shrinking El Niño numbers, then the 69% historic event forecast, stated in that same deflated index, in the same document, is a strange way to go about it. And underneath both of those there is the part that requires no trust at all. The methodology was published. The rationale is technical, specific, and written down. The historical series is recomputed transparently, which means the full record back to 1950 exists in both indices, side by side, and anyone with a spreadsheet can check what changed and by how much. A manipulation that publishes its own arithmetic and preserves the original series for comparison is not much of a manipulation. What is left, once you clear the conspiracy framing away, is a reading that is genuinely uncomfortable, and uncomfortable for everybody, which is usually the sign that you have arrived somewhere real. The index was changed because the ocean changed, and the new, stricter index still says this could be the biggest one ever measured, which returns us to the thread this whole video is pulling on. The disagreement between Hansen's record in the reservoir and NOAA's unremarkable surface number was never two camps arguing about the truth. It is one ocean being read by two instruments, and one of those instruments had to be rebuilt this year, because the baseline underneath it would not hold still. Every question in this story reduces to the same one. How much of what is coming belongs to the oscillation, the thing that peaks and passes, and how much belongs to the floor underneath it, the thing that does not go back down? We're going to spend the last hour on that question, but it is worth pausing here to establish something first, because so far this has all been documents and indices and arguments about measurement. It would be easy to come away thinking this is a forecast, a thing that might happen later if the models are right. It is not a forecast. It has already started. And the first place it showed up is nowhere near the Pacific. Part 8. The Atlantic is already answering. It is the end of August. The climatological peak of the Atlantic hurricane season is the 10th of September, roughly 2 weeks away. In an average year by this date, the basin has produced 5 or 6 named storms and 2 or 3 hurricanes, and forecasters are watching 2 or 3 waves coming off Africa at any given moment. This year the Atlantic has produced 2 named storms, Arthur and Bertha, and 0 hurricanes, not 0 major hurricanes, 0 hurricanes. NOAA's updated seasonal outlook, issued in August, calls for 7 to 13 named storms across the whole season, 2 to 6 hurricanes, and 0 to 2 major hurricanes. It puts the odds of a below normal season at 75%, near normal at 20%, and above normal at 5%. But the number that tells the story is not the forecast, it is the revision. Back in late May, before the season started, the same agency was calling for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 majors. 3 months later, every one of those ranges has been marked down, and the reason given is not that the Atlantic got colder. The Atlantic did not get colder. The reason given is El Niño. Here is the mechanism, and it is the cleanest demonstration in this entire video of how a Pacific anomaly reaches a place it has no business reaching. A hurricane is a vertical structure. It is a column, tens of thousands of feet tall, and it survives by keeping that column stacked, the warm core aligned from the sea surface all the way to the outflow at the top. Wind shear is what happens when the wind at altitude blows at a different speed or direction from the wind near the surface, and shear does to a developing storm exactly what you would expect. It leans the column over, decapitates the circulation, and ventilates the warm core with dry air before the storm can organize. El Niño produces shear over the Atlantic. Not directly. There is no wind blowing from Peru to Barbados. What happens is that the relocated thunderstorm activity over the central and eastern Pacific pumps enormous amounts of air upward. That air spreads out at altitude, and part of it descends over the tropical Atlantic, while strengthening the upper-level westerlies above the main development region. The result, 4,000 miles away, is a hostile ceiling over the exact patch of ocean where African easterly waves are supposed to turn into hurricanes. There is a name for the circulation doing this, and it belongs in the story because it is the same machinery we have been describing all along, seen from the side. The Walker circulation is the east-west overturning loop along the tropics. Air rises over the warm pool in the west, flows east at altitude, sinks over the cool eastern Pacific, and returns west along the surface as the trade winds. It is the atmospheric half of the Bjorken's feedback. During an El Niño, that loop weakens and shifts east. The rising branch relocates to the central Pacific, and because the tropical atmosphere is a single connected fluid, moving one branch of a circulation that spans the planet's waistline changes the flow over every basin it touches. The Atlantic is downstream of that adjustment. It always has been. This is why the correlation between ENSO and Atlantic hurricane activity is one of the oldest and most reliable seasonal forecasting relationships anybody has, established decades before the mechanism was fully mapped, simply because forecasters noticed that quiet Atlantic seasons kept coinciding with warm Pacific years. And it is worth stressing what is not causing this quiet season, because it rules out the easy alternative explanation. The tropical Atlantic is not cold. Sea surface temperatures there remain more than warm enough to build hurricanes. The fuel is sitting there untouched. What is missing is permission from the atmosphere above it. That is the fingerprint. 2 named storms and no hurricanes at the end of the August, in a basin whose sea surface temperatures are perfectly capable of supporting storms, because something in another ocean is holding the lid on. If you watched the video from August 23rd on the record heat spreading across the United States, this El Niño was already in it, riding along as a background thread, showing up in the ocean indices and in the strange emptiness of the Atlantic outlook, while the heat dome took the headline. That background thread is now the main story, and the empty Atlantic was its first legible signature. The Pacific has been signing its name on other basins for weeks. There is a second thing worth putting on the table here, and it comes straight out of Hansen's document, where he names it specifically. Lake Mead and Lake Powell, the 2 largest reservoirs in the United States, are at record low combined storage. In mid-July, Powell was sitting around 3,524 feet, roughly 23% full, the lowest July level ever recorded there. Mead was just under 1,043 feet, roughly 27% full, and less than a foot above its all-time record low. Taken together, the 2 of them have not held this little water since 1957, when Glen Canyon Dam was still under construction and Lake Powell did not exist as a reservoir at all. Now, I need to be very clear about something, because this is exactly the kind of pairing that gets misused. That deficit is not a consequence of this El Niño. It cannot be. It accumulated over roughly 2 decades of hydrological drought across the Colorado Basin, driven by reduced snowpack, earlier melt, higher evaporative demand, and a river that was over-allocated on paper before most of us were born. Nothing that happened in the Pacific this summer drained those reservoirs. It belongs in this video for a completely different reason, and it is the reason Hansen put it in his. Those reservoirs were engineered against a 20th century hydrology. The allocations, the dam heights, the intake elevations, the interstate compacts, all of it was calibrated to a distribution of river flows that was assumed to hold still, and it has not held still. The infrastructure is not failing because it was badly built. It is failing because the climatology it was built against has walked out from underneath it, which is precisely the same problem as the index, an instrument calibrated to a baseline that moved. One of them is a number on a NOAA webpage, and one of them is 40 million people's water supply, but structurally they are the same failure, and that equivalence is the argument Hansen is actually making, so hold both of those. A hurricane season already suppressed by an ocean on the other side of the world, and a water system already failing against a climate that no longer exists. One shows you that the oscillation is real and moving. The other shows you what the floor does when nobody's watching it. Now we go and find out where the heat itself lands. Part 9. The threshold that moves with the person. There is an assumption buried inside every heat warning ever issued, and almost nobody has ever examined it. The assumption is that there is a temperature at which the human body fails, and that it is the same temperature for everyone. That is what a threshold is. It is what a heat advisory means. When a weather service issues a warning at a heat index of 105 degrees, the implicit claim is that 105 is the number, the point at which the physiology of a person, any person, starts losing the argument with the environment. The whole architecture of public heat safety is built on the idea that the danger line is a property of the air. A study published in the Lancet Planetary Health this year finds that it is not. The lead author is Chin-Kin Kong, a postdoctoral scholar at Stanford Health Policy, working with Jeroen Ben David, a professor of health policy and medicine at Stanford, alongside Daniel Veselio, Matthew Huber, Larry Kenny, and others. What they did was combine two things that had not been properly combined before. On one side, laboratory measurements of heat tolerance. Real people in environmental chambers, instrumented with core temperature monitored while heat and humidity are gradually raised, until the body can no longer hold its internal temperature steady. Those experiments have been run for years, and crucially they have been run on young adults, on middle-aged adults, and on older adults separately. On the other side, population projections and climate projections mapped by region. Put them together, and you get the first global map of dangerous heat exposure broken down not by where people are but by how old they are. And here is why that had never been done. As the Stanford team points out, previous projections applied heat limits measured on healthy young adults to everybody, every age group. The tolerance line that had been used to estimate global heat risk was the line for a fit 25-year-old, applied to a planet where a rapidly growing share of the population is over 65. The finding that comes out of correcting that is the single most striking sentence in the whole study, and it is worth reading slowly. Older adults face more of this extreme heat risk at 1.5 degrees Celsius of global warming than young adults do at 4 degrees. Read that again. 1.5 against 4. The gap between a young body and an old body in terms of exposure to intolerable conditions is worth more than 2.5 degrees Celsius of planetary warming. Coverage of the study reported the tolerance thresholds themselves as running roughly 4.7 to 7.5 degrees Celsius lower for older adults than for young ones. 8 to 13 degrees Fahrenheit of difference between two people standing in the same room. The danger line is not a property of the air, it is a property of the person standing in it. And when you correct for that, the number of people facing repeated uncompensable heat exposure comes out 2 to 8 times higher than earlier studies had estimated. I want to be precise about what that phrase, can no longer maintain a stable core body temperature, actually describes, because it does not mean uncomfortable, and it does not mean sweaty. Your body runs at around 37 degrees Celsius, and it defends that number aggressively, because the proteins that run your cells are shaped to work in a narrow band around it. Heat comes in from the environment. Heat is generated internally by simply being alive. And heat goes out primarily by evaporating sweat off your skin, which is an extraordinarily effective cooling system right up until the air is too humid for the sweat to evaporate. The threshold the researchers are measuring is the point at which incoming heat exceeds outgoing heat, and the balance tips permanently. After that, core temperature does not stabilize at a higher level. It climbs. It keeps climbing for as long as the conditions hold, and there is no plateau because the control system has run out of authority. That is what compensable heat stress becoming uncompensable heat stress means, and it is why heat kills quietly and quickly in ways that catch people by surprise. Why does age move that line by up to 7.5 degrees? Several reasons, all of them mundane and all of them cumulative. Cardiovascular reserve declines, and shedding heat requires pushing a lot of blood to the skin, which is work the heart has to do on top of everything else it is doing. The sweat response blunts with age. Older skin produces less sweat per gland and starts producing it later. Thirst perception weakens, so dehydration arrives before the signal to drink does, and a great many people over 60 are taking medications, diuretics, beta blockers, anticholinergics, some psychiatric drugs, that interfere directly with thermoregulation, either by reducing fluid volume or by suppressing the sweat response itself. None of that is exotic. It is just the ordinary arithmetic of being older, and it means that a summer afternoon, which is genuinely fine for a 25-year-old, can be a physiological emergency for a 70-year-old standing in the same room. There is a second variable in those chamber experiments that deserves its own moment, because it is the one that decides whether a hot day is dangerous or merely unpleasant, and it is not temperature. It is humidity. Sweat only cools you when it evaporates. Evaporation is the phase change that carries heat away, and it requires the surrounding air to have room for more water vapor. When the air is already close to saturated, sweat stops evaporating and starts simply running off you, which cools nothing and costs you fluid. This is why a dry 95 is survivable, and a humid 95 is not. The two are not variations on the same conditions, they are different physical situations that happen to share a number on a thermometer. And this is where El Niño enters a story that has otherwise been about demographics. A warmer ocean puts more water vapor into the atmosphere, the carrying capacity of air for moisture rises steeply with temperature, and El Niño specifically redistributes that moisture, loading some regions and stripping others. The same event that dries out the Ethiopian highlands can push humid air over populations elsewhere. The heat that matters to a human body is not the heat on a map. It is heat and moisture together, and the ocean supplies both. Now the exposure figures, and this is where the study stops being about physiology and starts being about the shape of the century. At approximately 1.5 degrees Celsius of global warming, which is roughly where we are now, 22% of the world's population over the age of 60 is exposed to unsafe temperature levels for at least 1 month every year. More than 1 in 5. Already. Today. Not in a projection. Not under a scenario. At the level of warming that has already happened. And then the number that I think is the single most useful thing in this entire video, because it converts an abstraction into a unit that anybody can feel. Each additional degree Celsius of global warming exposes roughly 1 billion more people to at least 180 hours a year of heat their bodies cannot compensate for. 1 degree. 1 billion people. 180 hours. Hansen's group glosses that as a month of intolerable heat per degree per billion people, and I want to be precise about the difference, because the precision matters. 180 hours is not 30 continuous days. It is roughly 6 hours a day for a month, the hot part of each afternoon across the worst month of the year, which is exactly how heat actually kills. Nobody dies from a statistic spread evenly across a year. They die from the afternoons. And the study makes a point of saying that this exposure is not spread evenly. It concentrates in peak months. At under 3 degrees of warming, the authors find that older adults in the worst affected regions could face intolerable conditions repeatedly, through both day and night, for several consecutive months, which removes the overnight recovery that is the only thing standing between a survivable heat season and a lethal one. Stop and do what that number invites you to do. We are told to think about warming in tenths of a degree, and it sounds like a rounding error. The difference between 1.5 and 2.5 is a single degree, a number so small that in ordinary life it is beneath notice. You would not feel 1 degree walking outside, you would not feel it in a room, but that single degree is a month of unsurvivable conditions, arriving annually for 1 billion human beings. That is the exchange rate. That is what a degree buys, and the geography of it is not evenly spread either. At 3 degrees of warming, the study finds that India, China, Pakistan, and Bangladesh alone account for roughly 1.5 billion people facing repeated uncompensable heat, close to 3/4 of everyone affected worldwide. Pakistan stands out on both measures, with nearly 295 million people affected, more than 80% of its population. In Bahrain and Qatar, the figure is 100%. In the United Arab Emirates, close to 95%. And in 7 countries, including Bangladesh, Cambodia, and several Gulf states, the entire population over 65 is exposed. Kong put the purpose of the work plainly. The human body, she said, can tolerate only a limited range of ambient heat, and understanding where, when, and to what extent these limits are exceeded is critical for informing climate prevention policies. There is a demographic half of this finding that runs in the same direction as the climate half, which is what makes the study's title so exact. It is called Exceeding Human Heat Tolerance in a Warming, Aging World, and both adjectives are doing work. The share of the global population over 60 is rising in nearly every country on Earth, and it is rising fastest in some of the places where the heat exposure is worst. So the 2 curves are not independent. The number of people standing on the wrong side of that lowered threshold grows because the world is warming, and it grows again because the world is getting older, and those 2 increases multiply rather than add. Which means that even in a scenario where warming stopped tomorrow, which is not a scenario anyone is offering, the exposed population would keep climbing for decades on demographics alone. And this is exactly why the question this video keeps circling is not academic. The whole argument between the peak and the floor is an argument about degrees. An El Niño peak is a spike of a few tenths, and it passes. A shift in the baseline is a permanent addition, and it does not. Under this study's scaling, one of those is a season of unsurvivable afternoons that visits and leaves. The other is a season of unsurvivable afternoons that moves in. Part 10. What Europe counted this summer. Hansen's group put a number in their August 21st document that they did not generate themselves. They cited news reports. Excess deaths in Europe this summer, they wrote, already over 25,000 and rising. By the time I sat down to build this, days later, that number was already wrong. Not because anyone made a mistake, but because of how this particular kind of counting works. Europe's Euromomo monitoring platform was reported to estimate more than 32,000 excess deaths across the continent for the window running from mid-July to mid-August alone. Separately, an AFP tally of National Health Authority figures across 8 countries – Austria, Belgium, England, France, Germany, the Netherlands, Portugal and Spain – reached roughly 33,000 excess, or directly heat-attributed deaths for periods running from late May through August. Underneath the aggregate are the national counts, and they are worth hearing individually because aggregates flatten things. England recorded 2,877 heat-related deaths across the May and June heatwaves alone, and health authorities stated openly that the full-year figure would come in substantially higher once the later heat episodes were counted. Belgium recorded 2,570 excess deaths in a single month, between June 18th and July 17th. The gap between Hansen's 25,000 and the 33,000 that surfaced days later is itself worth understanding, because it tells you something about how this data behaves. Mortality reporting runs on a lag. Deaths are registered locally, then aggregated regionally, then aggregated nationally, and the pipeline takes weeks. Which means that during a heat season the published figure is always an undercount of the season to that date, not because anyone is hiding anything, but because the most recent weeks have not finished arriving yet. Every number you see during a heat wave is provisional, and every one of them revises in the same direction. So if you are quoting a figure from this summer, quote it with a date attached. 25,000 as of August 21st, 33,000 as of a few days later. Both were accurate when written. Neither is final, and the final one will be larger. Now here is the comparison that puts this summer in its place, and it is going to be uncomfortable in an unexpected direction. 2026 was not Europe's worst summer. The benchmark is 2022, when a peer-reviewed estimate put heat-related deaths across Europe at 61,672 between May 30th and September 4th. This year, by the counts available so far, is roughly half of that. Sit with that for a moment. 30-something thousand people, and it is the lesser figure. That is the comparison a warming baseline makes available to you. A summer that kills 30,000 Europeans and is not, by recent standards, remarkable. Because I know the objection that arrives next, let me deal with how these numbers are produced, since the debunk depends entirely on the method. Excess mortality is not an attribution of individual deaths. Nobody goes through 30,000 death certificates looking for the word heat. What you do is build a statistical expectation. How many people normally die in this country, in this week of the year, given the population's size and age structure, and the recent trend? Then you count how many actually died. The difference is the excess. It is the same technique used to count the true toll of influenza seasons, and the same technique used during the pandemic. It has been in use for over a century, and it is how the 61,000 figure from 2022 was derived and published in the peer-reviewed literature. So when somebody tells you the heat death tolls are inflated statistical artifacts, the honest answer has two halves, and only one of them is the half people expect. The first half: yes, there is genuine uncertainty. Excess mortality does not prove causation for any individual. A person who dies during a heat wave might have died that week regardless. The method captures a population-level signal, and population-level signals carry error bars, and anyone quoting these numbers to three significant figures is overstating what the method can deliver. The second half is the one that rarely gets said. The methodological criticisms do not all point in the direction of inflation. Heat deaths are routinely and substantially undercounted in official cause of death records, because the recorded cause is almost never heat. It is cardiac arrest. It is renal failure. It is a stroke. Heat is what pushed a compromised cardiovascular system over the edge, but the certificate records the edge, not the push. That is precisely why the excess mortality method exists, because the direct counts were known to be missing most of it. The uncertainty is real, and it does not point one way. It points both ways, and the honest position is that we know the number is large and we do not know it precisely. It is also worth knowing who these deaths actually happen to, because the pattern is remarkably consistent across every heat season that has been studied properly. They are overwhelmingly older people. They are disproportionately people living alone, without anyone to notice that the flat has become dangerous. They cluster in cities rather than countryside because a built environment made of asphalt and masonry absorbs heat all day and releases it all night. And a large share of them occur not during the hottest afternoon, but after several consecutive days without relief, because the body recovers overnight, and if the overnight temperature never drops far enough, that recovery does not happen, and the strain accumulates across days rather than resetting each morning. Which is why the duration of a heat event, and specifically the behaviour of its nighttime minimum, is often a better predictor of the death toll than the peak daytime temperature that generates the headline. There is one more thing in Hansen's document about this, and it is the part that should sit least comfortably with anyone in a wealthy country. He names the regions where the exposure is worst: South Asia, the Gulf nations and Africa, and specifically India, Pakistan, Bangladesh, Myanmar and Niger. Those are places that combine very large populations with high rates of poverty and very limited access to cooling. And he makes an observation that cuts against the easy optimism. Greater use of air conditioning may well reduce future fatalities in Europe. It will not reach those populations. Air conditioning is a solution available to people with reliable electricity and disposable income, which describes the parts of the world that are, for the most part, not the parts of the world where this is worst. So the ledger reads like this. A summer that was not Europe's worst still produced tens of thousands of excess deaths, on a continent with the medical infrastructure and the wealth to respond, on a floor that has risen since 2022. And the peak has not arrived yet. Part 11. The calendar. Nobody watches. Here is the thing that took me longest to understand about El Niño, and it reframes everything. The risk is not the anomaly. The risk is where the anomaly lands in a crop calendar. Rain that fails in a month when nothing is growing costs almost nothing. This same rainfall deficit, arriving 8 weeks earlier, can take out a national harvest. The atmosphere does not know or care about planting dates. The consequences care about nothing else. Which is why the most useful document I read while building this was not a climate paper. It was a briefing note published on June 3rd of 2026 by Weltungerhilf's Anticipatory Action Facility, an organisation whose entire job is to move resources before a disaster rather than after one. Their briefing synthesises FuseNet, the UK Met Office, the World Meteorological Organisation's coordination mechanism, the 73rd Greater Horn of Africa Climate Outlook Forum, and the GeoGlam Crop Monitor. It is not a forecast of doom, it is a logistics document, and that is what makes it credible. Start with the Greater Horn of Africa, because that region has the sharpest signal. The 73rd Climate Outlook Forum, covering June through September of this year, found an increased likelihood of below normal rainfall across most of the areas where those months are the main rainy season. South Sudan, Uganda, Ethiopia, Djibouti, much of Eritrea, much of southern Sudan, western Kenya. The probabilities exceed 60% across substantial areas, and they peak at 80% in Ethiopia and South Sudan. 80%. That is not a hedge. In seasonal forecasting, 80% on a regional rainfall category is about as confident as the science gets, and those months are not incidental. June through September is when rain-fed production happens across a large part of that region, when pasture regenerates, when water points refill, and when the hydropower reservoirs that supply the electricity take on their water for the year. A dry June to September in the Ethiopian highlands is not a weather story. It is a food story, a water story, and an electricity story simultaneously. Somalia carries its own flag in the same briefing. Concern around GU-season cereals, with seasonal rainfall running below 30 to 45% of average across most areas by late April, and poor distribution of what did fall, which matters as much as the total, because rain that arrives all at once and then stops is worse for a crop than the same amount spread out. Now Southern Africa, and this is the sharpest fact in this entire section. Southern Africa's main maize season runs from December through March. One season. There is no second attempt, no spring planting to fall back on, no alternative window. Maize is the staple across an enormous swathe of that region, and the calendar is fixed by the rains. December through March is precisely the window in which this El Niño is forecast to peak. The briefing is careful to say that the concern is for the 2026 into 2027 rainfall season rather than right now, and that current crop conditions across the region are mixed rather than bad. The recommendation is preparedness, not panic. Seed availability, drought-tolerant varieties, livestock water planning, reviewing national contingency plans, which is exactly what an anticipatory action organisation should be saying in August. But the alignment of the peak and the planting window is not a coincidence anyone can plan around. It is just the calendar. Elsewhere on the map, the same document flags drier than normal signals across large parts of India, Pakistan and Nepal for the southwest monsoon, and identifies the strongest dry signal of all across Indonesia and Papua New Guinea, which raises wildfire likelihood in exactly the peat-rich landscapes that burned so catastrophically in 1997. In Central America, the crop monitor flags the start of the Primera season in Guatemala for rainfall deficits and high temperatures, with elevated risk of below-normal rainfall running from May through September and beyond, meaning multiple consecutive cropping seasons, not a single bad one. And FuseNet projects that food assistance needs in November of this year will be highest in Sudan, the Democratic Republic of Congo, Nigeria and Yemen, followed by South Sudan, with needs higher than last November in a longer list that also includes Somalia, Lebanon, Burundi and Mali. Which is the reminder that a climate anomaly does not arrive in an empty room. It arrives on top of conflict, displacement, market disruption, and, in several of those countries, reduced humanitarian funding. It is worth walking the chain by which a rainfall probability becomes a hunger outcome, because it is longer than most coverage suggests, and every link in it is a place where the outcome can still be changed. A seasonal forecast indicates a raised chance of below-normal rain. Farmers, who are not passive in this, decide what to plant and when, and a delayed or erratic onset is often worse than a straightforwardly dry season, because it induces planting into moisture that then disappears, and a failed germination costs the seed as well as the harvest. If the crop establishes and then hits a dry spell at flowering, the yield falls even if total rainfall looks adequate on paper. Meanwhile, pasture fails to regenerate, so livestock body condition drops. So herders sell animals early into a market that is already flooded with other people's animals, so livestock prices collapse at precisely the moment cereal prices rise. That scissor, animals cheap, grain expensive, is what actually breaks pastoral households, and it happens months before anybody counts a hunger statistic. Every one of those links is visible in advance. That is the entire premise of anticipatory action. Monitor rainfall onset, soil moisture and vegetation indices, pre-position drought-tolerant or short-cycle seed, support replanting where the first attempt fails, get water trucking and animal vaccination in place before the stress peaks rather than after, which is why a briefing published in June about a season that peaks in December is not premature. It is the only moment at which the information is still useful. Now here is why I trust this briefing more than most of what will be written about this El Niño over the next 6 months. It argues against itself. Quoting it directly, the term Super El Niño should be used cautiously. The evidence supports a high likelihood of El Niño and a significant possibility of a strong event, but not guaranteed severe impacts everywhere. And alongside that, the note that climate impacts will not depend only on El Niño intensity, but also on its timing, the Indian Ocean dipole, regional and local factors, and pre-existing vulnerability. That is an organisation whose funding case would be strengthened by alarm, telling its own readers not to be alarmed prematurely. You should weight that heavily. I do. But notice what they are being cautious about. They are being cautious about the peak, about this event, this season, these months. And they are right to be. What no briefing in that stack can tell a farmer in Zambia is what the floor will be in 2035, because that is a different question, measured with a different instrument, and it is the question the last hour of this video is about. Part 12. The two events we keep comparing this to. There are only two events in the reliable record that anybody sensibly compares this one to, and it is worth spending a few minutes on what they actually did, partly because the numbers are extraordinary, and partly because of what happens when you notice what both of them have in common. Start with 1997 into 98, the benchmark, the one this event has already passed on the subsurface metric. At its peak, that El Niño temporarily warmed global air temperature by roughly 1.5 degrees Celsius. A typical El Niño contributes something closer to 1/4 of a degree. That event was 6 times the usual push, and it is why 1998 stood as the warmest year in the instrumental record for years afterward, and why an entire generation of arguments about whether warming had paused were built on the awkward fact that the following years struggled to beat it. The economic figures for that event are a lesson in reading numbers carefully, because they differ by nearly an order of magnitude depending on how you count. NOAA's estimate of direct global economic damage, property, crops, infrastructure, the things you can point at, comes in at $35 to $45 billion. Long-horizon econometric modelling, which measures suppressed economic growth over the following decade rather than immediate damage, produces figures in the trillions. Both numbers are honest. They are answers to different questions, and anyone who quotes one without naming the method is misleading you, usually accidentally. The human texture is what I remember. Agricultural and peatland fires burning out of control across Sumatra and Kalimantan, because the drought dried out peat that is essentially compressed carbon and does not stop burning once it is lit. The haze from those fires spread across Singapore, Malaysia and Thailand, and over 20 million people reported respiratory problems. Not 20 million exposed, 20 million reporting symptoms. The peat is the detail that turns that from a fire story into a climate story. Tropical peatlands are waterlogged accumulations of partially decayed plant material, built up over thousands of years, and they are essentially a carbon store held in place by water. Drain them or dry them, and they become fuel. Fuel that burns downward, underground, smouldering below the surface where no firefighting method can reach it, sometimes for months, and re-emerging somewhere else. A peat fire does not go out because you put water on the top of it. It goes out when the rains return, which during an El Niño is the one thing that is not going to happen on schedule, and roughly 16% of the world's coral reef systems died. That number deserves a sentence on mechanism, because bleaching is one of the most misunderstood processes in ocean science. A coral is not a single organism. It is an animal hosting photosynthetic algae inside its own tissue, and the algae supply most of the coral's food while the coral supplies shelter and nutrients. It is one of the most successful partnerships in the history of life. Push the water a couple of degrees above the local summer maximum for a few weeks and the partnership breaks down. The algae's photosynthesis starts producing damaging compounds under heat stress, and the coral expels them. What is left is the white calcium carbonate skeleton showing through transparent tissue. That is the bleaching. The coral is not dead at that point. It is starving, and it can recover if the water cools quickly enough. If it does not cool, the coral dies, and what killed it was a temperature excursion of 2 or 3 degrees sustained for weeks. 2 or 3 degrees, sustained, that is the entire margin. Then 2015 into 16, the other benchmark. That one triggered more than $5 billion in humanitarian appeals across nearly 24 countries, with more than 60 million people affected. It also drove a multi-year extreme drought and fire episode in Amazonia that has been costed at roughly $26 billion. The reef thread runs straight from there to here. NOAA confirmed the 4th global coral bleaching event on April 15th of 2024, and it ran on into 2025, accumulating heat stress across the world's reef area at levels well beyond any previous global event. If you watched the video from August 7th on Earth Systems, we covered the live marine heat wave in the Northeast Pacific, the largest since 1982, sitting off the west coast of North America. Same phenomenon, different basin, same rising floor underneath both of them. And that is the thing both of these historical analogues have in common, and the reason I have put them here rather than at the front of the video where they would normally go. Both of them landed on a measurably cooler planet than the one this event is landing on. 1997 happened on a world roughly half a degree cooler than today's. 2015 happened on a world a few tenths cooler, which means they are excellent guides to mechanism, to how an El Niño moves rain, suppresses hurricanes, kills reefs, burns peat, and they are close to useless as guides to magnitude, because the one variable that would let you scale them forward is the variable that has changed. Every comparison you're going to hear over the next 6 months will be missing that. Somebody will tell you this is like 97, and they will mean it helpfully, and the mechanism part will be right. The magnitude part will be an estimate built on a planet that no longer exists, which is the entire argument the last part of this video is about, because the man who wrote the document we started with did not title it Super Duper El Niño. He titled it Super Duper El Niño and the bigger problem. We have spent an hour and a half on the El Niño. Now the bigger problem. Part 13. The energy that does not oscillate. Everything in this video so far rests on a distinction that almost never gets made explicitly, so let me make it now, as plainly as I can. El Niño moves heat. It does not make heat. That is the whole thing. That single sentence is the difference between the two halves of this story, and once you have it, a great deal of confusing climate coverage suddenly sorts itself out. Walk the accounting. During the recharge phase, the trade winds pile warm water into the western Pacific and press it downward, burying heat below the surface where the atmosphere cannot get at it. During the discharge phase, an El Niño, that heat comes back up and east and gets exhaled into the air. Global mean surface temperature rises, sometimes dramatically, for a year or two. Then the system overshoots into La Niña, cold water floods the eastern Pacific, heat gets buried again, and the global temperature number falls back. Nothing was created in that cycle. Nothing was destroyed. Heat moved from a place where the thermometers could not see it to a place where they could, and then moved back. The books balance perfectly. Now here is what does not balance. The Earth absorbs energy from the sun and radiates energy back to space as infrared. If those two quantities are equal, the planet's temperature is stable. If more comes in than goes out, the planet accumulates energy, and it has to accumulate it somewhere. In the ocean, in the ice, in the ground, in the air. That difference is called Earth's energy imbalance, and it is the single most fundamental number in climate science, because everything else is downstream of it. The remarkable thing about that number is that we measure it two completely independent ways. The first is from orbit. Satellite radiometers looking down at the planet measure absorbed solar radiation on one side of the ledger and outgoing long-wave radiation on the other, and subtract. That is a top-of-atmosphere measurement, made with instruments that have nothing whatsoever to do with the ocean. The second is from inside the ocean itself. The Argo Array is a fleet of several thousand autonomous floats distributed across the world's oceans, each one drifting at depth, periodically rising to the surface while recording temperature and salinity on the way up, transmitting the profile by satellite and sinking again. Roughly 90% of any excess energy the planet accumulates ends up in the ocean because of that heat capacity we established at the very start. So if you can measure how fast the ocean's heat content is rising, you have measured the imbalance from the receiving end. Two methods, different instruments, different physics, different failure modes, different teams, nothing in common except the planet they are both looking at. Norman Loeb, who runs the satellite side of that comparison at NASA's Langley Research Center, described the result this way. The two very independent ways of looking at changes in Earth's energy imbalance, he said, are in really, really good agreement, and they're both showing this very large trend, which gives us a lot of confidence that what we're seeing is a real phenomenon. I want to draw attention to how a scientist expresses certainty, because it is worth learning to read. He did not say the trend is undeniable. He said two independent methods agree, and that agreement is why we have confidence. That is what real confidence sounds like. It is always a statement about corroboration, never a statement about conviction. And what they agree on is that the imbalance has approximately doubled. Peer-reviewed work published last year found it has more than doubled in recent decades. Hansen's group calls that doubling the proximate cause of the accelerated warming rate, and adds 4 words that carry more weight than anything else in the document. It is not declining. The 2 papers underneath that finding, for anyone who wants to go and check, Loeb and colleagues in Geophysical Research Letters in 2021 for the satellite record, and von Schuckmann and colleagues in Earth System Science Data in 2020 for the ocean heat storage calibration. There is a detail in how the imbalance widened that is worth knowing, because it is not the one most people assume. The obvious mechanism would be the outgoing side. More greenhouse gas, less infrared escaping to space. That is happening. But a large part of the recent widening shows up on the incoming side instead. The planet is absorbing more sunlight than it used to because it is reflecting less of it back. Earth's reflectivity, its albedo, is set by ice, by snow, by desert sand, by aerosols, and above all by clouds. Bright low cloud over the ocean is one of the most important cooling structures on the planet, and the observed decline in reflectivity in recent decades appears to involve less of it. Some of that is the aerosol change we will come to shortly. Some of it appears to be a feedback, a warmer surface producing conditions that thin and reduce the reflective cloud decks, which lets in more sunlight, which warms the surface further. That is the same architecture as the Bjerknes feedback from Part 3, operating on a planetary scale rather than a basin one, a loop that, once engaged, supplies its own push, which is why the phrase Hansen's group attaches to the imbalance, it is not declining, is the most important 4 words in their document. Now put the imbalance and the oscillation next to each other, because this is where the debunk writes itself. You will hear, over the coming months, some version of the argument that all of this is just El Niño, that the heat, the records, the drought, the reservoir lows are a natural oscillation doing what it has always done, and that reading anything more into it is hysteria. The answer is not a matter of opinion, and it does not require you to trust a single scientist. An oscillation on a flat line returns to where it started. That is what the word means. A pendulum swings out and comes back. If El Niño was simply an oscillation on a stable climate, then each El Niño peak would be roughly as warm as the last one, and each La Niña trough would be roughly as cool as the last one, and the whole thing would trace a band that goes sideways through time. That is not what the record shows. Each successive El Niño peak has been warmer than the one before it, and, this is the decisive half, so has every La Niña trough between them. The cold years are now warmer than the hot years used to be. A La Niña in the 2020s is warmer than an El Niño in the 1980s. An oscillation cannot do that. Only a rising line with an oscillation riding on it can do that. The pendulum is swinging exactly as it always did. The entire clock is being carried up a hill, and the imbalance is the reason. It is measured independently of ENSO, by instruments in orbit and floats in the sea, and it does not oscillate with El Niño. It does not care what the trade winds are doing. It is the arithmetic of energy in versus energy out, and it has been running a surplus for decades. Now the mirror image of that error, because it is just as wrong and it gets made just as often, usually by people who think they are on the right side. Attributing all of this to greenhouse warming is also incorrect. The westerly wind anomalies, the displaced thermocline, the southern oscillation index sitting 2 standard deviations negative, the thunderstorms picking themselves up off Indonesia and walking east. That is textbook ENSO, running a mechanism worked out 60 years ago, and it would be doing it on a planet with pre-industrial carbon dioxide levels. Waving at all of it and saying climate change is not analysis. It is the same failure of thinking as the first error, pointed the other way. Both things are true simultaneously. There is an oscillation, and it is doing exactly what oscillations do. And there is a rising floor underneath it, and it is doing exactly what a rising floor does. The interesting question, the only interesting question, is the ratio between them, and we will get to that. One more piece before we leave the energy budget, and it is the piece that connects the imbalance directly back to the ocean we started with. Marine heat waves. Hansen's group tracks them not as a separate topic, but as an acceleration indicator, and the reasonings in the published literature they cite. Marine heat waves have increased in frequency and duration over the past century in response to global warming. That is work published in Nature Communications in 2018. What Hansen's group adds is the observation that recently their intensity has been increasing faster, coincident with the acceleration in global warming, and they note something about the timing of them that is quietly unsettling. Marine heat waves tend to be more extreme in summer, when the ocean surface mixed layer is at its thinnest and the winds are at their calmest. A thin mixed layer means the incoming heat is being spread through less water, so the same energy produces a larger temperature rise. Calm winds mean less mixing to carry that heat downward and away, which means the ocean's ability to absorb a shock is not constant through the year. It has a weak season, and that weak season is precisely when the heat is most intense. The last number in this part is the one that carries into everything that follows. Temperature change over land is roughly twice as large as temperature change over ocean. During the 2023-24 event, land reached plus 2.4 degrees Celsius against the 1880 to 1920 baseline, and Hansen's group projects land approaching plus 2.7 in 2027, nearly 5 degrees Fahrenheit, over the continents where everybody lives. That number is what the energy imbalance eventually turns into, once it has been through the ocean, through the atmosphere, and through the asymmetry between water and dirt. And whether that number keeps climbing at the rate it has been climbing is the subject of the sharpest argument in climate science right now. Part 14. The argument scientists are having in public. I have been putting this off for an hour and a half, and it is time. Hansen's group holds a position that is not the consensus position, and they state it in the document we have been working from. They write that climate sensitivity is significantly higher than the best estimate of the Intergovernmental Panel on Climate Change, and that the net human-made climate forcing, including aerosol effects, is now larger than the panel's best estimate. Those are two of the most consequential numbers in the entire field. Climate sensitivity is, roughly, how much warming you eventually get from a doubling of atmospheric carbon dioxide. Net forcing is how hard the planet is currently being pushed. If Hansen's group is right about both, then the world is being pushed harder than official assessments say by a system that responds more strongly than official assessments say, which compounds into a very different century. The specific claim underneath it, published last year, is a number about rate. The warming rate ran at about 0.18 degrees Celsius per decade from 1970 to 2010. Since 2010, they put it at least 0.27 degrees per decade. That is roughly a 50% increase in the speed of warming inside 15 years. And the mechanism they propose for it is genuinely one of the strangest stories in modern environmental policy. For most of the industrial era, burning coal and heavy fuel oil put enormous quantities of sulfur into the atmosphere, where it formed sulfate aerosols, tiny reflective particles that scatter incoming sunlight back to space and also seed brighter, longer-lived clouds. Those particles were killing people. Sulfate aerosol pollution is directly implicated in respiratory and cardiovascular death on a scale of millions per year, and cleaning it up is one of the great unambiguous public health achievements of the last half-century. They were also, the entire time, holding a reflective shield over the planet. The tightening of sulfur limits, in power generation, and then in 2020 in marine fuel, which cut permitted sulfur content in shipping fuel by roughly 85% overnight across the world's oceans, removed a substantial part of that shield. More sunlight reaches the surface. Absorbed solar radiation goes up. The energy imbalance widens, and the warming that was already committed but was being masked arrives. Sit inside the shape of that argument for a second, because it is not comfortable in any direction. Cleaning the air saves lives, and it is unambiguously the right thing to have done. it also removed a cooling effect that was hiding warming we had already bought. Two true things, pulling opposite ways, and no version of the story where somebody is simply the villain. Now the counter-argument, and I want to give it properly, in the terms its holders would use, because a great deal of coverage of Hansen skips this step entirely, and it is not honest to skip it. A substantial part of the climate science community argues that the recent warming sits within the range that model ensembles already project, particularly when those ensembles are screened for realistic transient climate response, and that Hansen's group is reading a trend into a record too short to support it. 15 years is not very long. 15 years is exactly the length of record in which spurious trends live, because natural variability, including, pointedly, El Niño, can generate apparent accelerations and decelerations that vanish when you extend the window. This is the same statistical trap that produced the so-called warming pause of the 2000s, which turned out to be an artifact of starting the clock in 1998, the year of the biggest El Niño in the record. The critics are not saying the planet is not warming. They are saying that declaring a statistically robust acceleration and revising climate sensitivity upward on the strength of it is premature, and they are pointing out that the person arguing for it has, historically, been the most aggressive forecaster in the field. Here is the honest scoreboard. Hansen's group has been making this argument since around 2020. Since then, the subsequent years have gone their way more often than not. The temperature records arrived. The energy imbalance widened. The 2023 anomaly that nobody could explain was, by the acceleration argument, roughly what you would expect. That is a track record, and it should count for something. It is also not the same thing as being settled, and Hansen's group would presumably agree, because their entire position is an argument for updating faster in response to data, rather than an argument for having been right all along. And unlike most public arguments, this one has a mechanism for ending, which is worth spelling out because it tells you what to watch for. If the acceleration is real and aerosol-driven, then the energy imbalance should stay wide, the ocean heat content should keep climbing at the faster rate, and the warming should continue at close to the higher figure through the second half of this decade, including through the La Niña years when the surface temperature number falls. That last part is the cleanest test available. Surface temperature during an El Niño tells you almost nothing, because the oscillation dominates the signal. Surface temperature and ocean heat content during the cold phase that follows tell you a great deal, because the oscillation is pushing the other way, and whatever is left over is the trend. So the years that will settle this argument are not the loud ones. They are the quiet ones on the far side of this event, and they are perhaps 3 to 5 years out. Why does this particular disagreement decide the whole video? Because it is the peak versus floor question in its purest form. If the acceleration is real, the floor is rising faster than the models assumed, and the El Niño peak matters comparatively less. It is a spike on a line that is climbing steeply, and the line is what will define the 2030s. If the acceleration is not real, then this El Niño is a large transient on a slower trend. The world will get an alarming 18 months and then a partial reprieve, and the floor is closer to where the official assessments put it. Same ocean, same data, 2 completely different next decades, and there is a practical dimension to the disagreement that goes well beyond who wins an argument in a journal. Climate sensitivity is not an academic quantity. It is the number that sets carbon budgets. How much more can be emitted before a given temperature threshold is crossed? Raise sensitivity and every remaining budget shrinks. Raise the estimate of net forcing and the timeline compresses further. The numbers Hansen's group is disputing are the numbers that international agreements are written against, which is exactly why the dispute is fought as hard as it is, and why both sides have reason to be extremely careful. There is also an unpleasant irony sitting in the middle of it. If the acceleration is substantially driven by removing aerosol cooling, then part of what we are experiencing now is not new warming at all. It is old warming, already paid for decades ago, that was being held behind a curtain of pollution. Take the curtain down, for excellent reasons, saving a great many lives, and the bill arrives. That would mean some fraction of the 2020s is not the future arriving early. It is the past being revealed. Which brings me to the thing I actually want to say about all of this. You will encounter the claim, you may already have encountered it, that scientists privately know it is far worse than they say publicly, and that there is a systematic effort to keep the real numbers out of view. Hansen gets cited as evidence for this constantly, usually by people who have not read him. Look at what this story actually shows. Hansen is one of the most published and most covered climate scientists alive. He publishes his disagreements with the IPCC openly, repeatedly, under his own name, with the arithmetic attached. His critics publish their rebuttals just as openly, in the same journals and on the same public websites, also under their own names, also with the arithmetic attached. Anyone with an internet connection can read both sides in an afternoon. The data underneath the dispute, the satellite radiation record, the Argo profiles, the temperature series, the ENSO indices in both the old and the new formulation, is publicly downloadable. That is not what a cover-up looks like. That is the opposite of what a cover-up looks like. It is an argument being conducted in public, in the literature, in real time, by people who are staking their professional reputations on being right. And I would put it more strongly. A field in which nobody disagreed would be the thing to worry about. Unanimity in a young science with short records and enormous stakes would be a sign that something had gone wrong with the process, not a sign of certainty. What we have instead is a genuine, sharp, well-documented dispute between serious people, with a resolution date, because the data keeps arriving whether anybody likes what it says or not. And notice what is not in dispute. Nobody in this argument is questioning whether the planet is accumulating heat. The energy imbalance is measured two independent ways and they agree. The disagreement is about attribution and sensitivity, about why it is accelerating and how much warming it eventually buys, not about whether the surplus exists, which leaves exactly one question standing. It is the question we have been circling since the first 10 minutes, and every single thing in this video has been assembling the parts needed to ask it properly. Part 15. Peak or floor. Put the two numbers back on the table, side by side, exactly as we found them. A record in the upper 300 meters of the equatorial Pacific, exceeding 1997 and 98, with the peak still months away, and plus 1.4 degrees Celsius at the surface in July on the index the world actually quotes. Everything in the last 2 hours has been about the space between those two numbers. So let me lay out what that space could mean, honestly, without pretending that one reading is obviously correct, because it is not, and anybody telling you otherwise is selling something. The first reading is the simplest. The surface has not caught up yet. Under this interpretation, the reservoir is loaded and the withdrawal has barely started. The subsurface heat is staged, the thermocline is deep, the Kelvin waves are still crossing, and October through December is when that exchange typically peaks. Which means the visible numbers, global mean temperature, marine heat wave extent, the eastern Pacific surface field, the drought maps, the crop reports, have a very long way still to climb, and it means 2027 is the year the consequences actually land, not 2026, for the same lag reason that put 1998 rather than 1997 in everybody's memory. If that reading is right, then this autumn is the beginning and not the middle, and the numbers we have been quoting all evening are going to look small by March. The second reading is Hansen's, and it cuts against treating this El Niño as the protagonist at all. If the planet's energy imbalance has roughly doubled and the warming rate has stepped up, then every El Niño from here forward arrives on a higher floor, which means the size of the peak matters less than the height of the thing it is standing on. Under this reading, the record subsurface anomaly is a symptom rather than a cause, an expression of an ocean that has more heat in it than it used to, behaving in the way an ocean with more heat in it would behave. And the diagnostic number stops being degrees and becomes degrees per decade. That is the same variable in a different ocean that we found 10 days ago in the Atlantic overturning work, where the collapse threshold turned out to be a rate rather than a level. Two entirely separate bodies of research, on two different oceans, arriving at the same conclusion about which quantity is doing the deciding. That convergence is not nothing. The third reading is the one I keep coming back to, because it is the only thing in this entire story that is not a projection or a contested attribution. The measurement crisis is the actual news. Everything else here is an argument. Hansen's human-driven claim is an argument. The acceleration is an argument. The 69% is a probability. The Southern Africa forecast is a probability. All of it is contestable, and all of it will be contested. But in February of 2026, the agency responsible for defining El Niño changed the definition because the reference ocean had drifted far enough to break the old one. That is not a projection. That is an administrative fact with a date on it, an institution formally conceding in public, in a technical document, that the 20th century baseline no longer functions as a baseline. If you want one thing to carry out of this video, and you do not want to have to trust anybody's model to hold it, that is the thing. The ruler was replaced. It was replaced because the world it measured against had moved. The fourth reading relocates the story from the atmosphere to the people standing in it. A world that is aging and warming at the same time does not need record temperatures to produce record mortality. It needs ordinary summers applied to older bodies, on a threshold that has quietly dropped by up to 7.5 degrees for the people most exposed to it. Europe just demonstrated that. A summer that was not the continent's worst on record, on a continent with the wealth and the hospitals to respond, still counted more than 30,000 people it should not have. And the fifth reading, which I am not going to bury at the bottom as a hedge, because it deserves the same weight as the others. The forecasting institutions themselves are urging restraint. The anticipatory action briefing said in plain language that the term Super El Niño should be used cautiously, and that severe impacts are not guaranteed everywhere. NOAA's own discussion said that impacts consistent with El Niño become more likely with an event of this magnitude, but are not guaranteed. These are the people closest to the data, with the most to gain from alarm arguing for less of it. Some regions on this risk map are going to come through the next 18 months without much happening. Some seasons that look threatened in August will be fine in March. El Niño loads dice. It does not write scripts. And a channel that tells you the dice always come up sixes is not a channel that is telling you the truth. Now let me bring the through line of Hansen's document into the open, because it has been standing behind everything, and it deserves to be said directly. Many living spaces occupied based on 20th century climate, he writes, will not be well suited to habitation later in the 21st century. That is not a sentence about weather. Read it again and notice how little of it is about the sky. It is a sentence about siting, about where cities were built and why, which was almost always because of water, a river, a harbour, an aquifer, a snowpack upstream. It is a sentence about where water rights were allocated, in negotiations conducted decades ago against flow records that were assumed to represent the long-run average, about which crops were bred for which valleys and against what growing season length, and with what expectation of frost dates, about what wind load a building was engineered to survive, and what storm intensity a culvert was sized for, and what flood elevation an intake was set at. Every one of those decisions was a bet on a climatology, and a climatology is a distribution, a statement about what the range of normal is and how often you leave it. We have already seen this evening what happens when the distribution moves and the instrument does not. Lake Mead and Lake Powell, at their lowest combined storage since 1957, are not failing because anybody built them badly. And the Oceanic Niño Index was not a bad index. Neither of them was wrong about the world they were designed for. They were both overtaken by a different world arriving underneath them, and nothing about either of them announced it. That is the bigger problem. It has almost nothing to do with any individual hot summer. It is the slow invalidation of the reference frame that every long-lived decision was made inside, and it scales. Start with this one basin, a slab of ocean 5,000 miles wide holding more heat than anything has recorded before. Widen out and it is the whole planet's energy budget, running a surplus that is measured two independent ways and is not declining. Widen again and it is a fact about oceans generally, which is that they have always been the buffer between the atmosphere and the consequences, absorbing roughly 90% of the surplus and hiding it below the surface where no thermometer on land will ever find it. That buffer is why the surface of the Earth has warmed as slowly as it has. It is also why we should be careful about feeling reassured by it. A buffer is a delay. It is not a cancellation. Everything the ocean has absorbed is still in the ocean, and the only question is the schedule on which it comes back out. And an El Niño, stripped of everything else, is exactly that. It is the ocean handing some of it back early. We have always assumed that the oscillation was the story, and the baseline was the background. That the interesting question was how big the swing would be, and the level it swung around was a fixed thing you did not need to think about. But what if the baseline was the story all along, and the oscillation was only ever the thing that made it visible, because that is what this event may turn out to be. Not a catastrophe in its own right, a floodlight. Something that comes along every few years, briefly illuminates how much heat is actually in this system, and then switches off again, leaving behind a number that is higher than it was the last time the light came on. So here is the thread, stated one final time in its cleanest form. The strongest El Niño in the modern record is being measured against an ocean that no longer matches the one the measurement was built for. Which means the question was never how big this is. The question is how much of it goes back down. On September 10th, the Climate Prediction Center issues its next diagnostic discussion. It is a routine document, it will get almost no coverage, and it is the first real checkpoint on everything in this video. It will either hold that 69%, raise it, or back away from it. And buried in it will be the number that actually matters, which is what the surface has done. Whether Niño 3.4 has started climbing toward the heat that is sitting 300 meters beneath it. If it has, then this is a very large El Niño behaving the way very large El Niños behave, and we are in for a difficult 18 months of a kind that history at least gives us a template for. But if it has not, if the reservoir keeps setting records and the surface simply refuses to follow, then the relationship between the heat below and the heat above has changed. And that would be a far bigger story than this El Niño.